Yes, sir. Thank you, Society of Power Engineer, for giving me this opportunity to deliver whatever I know. So, thanks a lot for giving me this opportunity. So, today's topic is I'm going to explain a Power World simulator, that how we can do various experiments, various analysis with the Power World simulators. So, my presentation will be divided into two parts. Because of lack of time, what we do is I introduce a software to you, certain shortcuts, certain key icons, components to you, and in second part I try to explain one of the example of IEEE 5-bus load flow analysis in this Power World simulator. So this will be the outline I will try to cover. That first is introduction, second is I will discuss IEEE 5-bus load flow analysis, how small analysis we can perform on Power World simulator. And if time permits, we go with fault analysis. So the Power World simulator, it's a user friendly software, and it is highly interactive software for power system analysis and visualization. Now many times many of you or some of you come across the MATLAB software. So what you know that in MATLAB software, majority of the things you have to visualize because details are available in data forms, and many a times it is difficult to rightly judge what is occurring in this system. So compared to that, if you deal with this Power World software, it will give you the clear-cut idea that what will be the power flow direction. If I discuss the power flow case, what will be the direction of power flow, what amount of power is being exchanged, what is the power loss, everything is visualized. So that is the benefit of this Power World software, that visualization is there, so data interpretation analysis will be very effective compared to the other packages where you have to imagine the scenario. This software, with the help of this software, we can perform the various tasks like contingency analysis, time step simulation, optimal power flow, available transfer capability, PV/QV voltage stability analysis, fault analysis, security constraint, optimal power flow, sensitivity analysis, loss analysis, transient stability, and geomagnetically induced current. So these various cases can be performed, or various analysis can be done in Power World simulator. Nowadays it is designed to operate even on Windows 10 also. So Windows 7, 8, 10, 11, it will work easily, and the size of the software is very compact. So a few things about the Power World simulator, that version 1 is created in May 1994 at the University of Illinois by Professor Thomas Overbeck, and this was designed to teach the non-technical audience in the starting. Later on it is coming for this technical analysis and for professional users. So Power World Corporation was formed in 1996 for further development of this simulator tool, and the capacity of this Power World Simulator 23 is it can handle 250,000 of buses. So that is the capacity of this Power World software version 23. So these are the training goals, that how we can deal with the power systems, this Power World software, and how we can analyze the system. That will be the training goals. So first I will show you the glimpse of this Power World software. So it integrates two functions. One is the graphical power system case editor, and second is coming with the packages, that is analysis tools, contingency analysis, time step, fault analysis, optimal power flow, and ATC and security constraint, optimal power flow, these cases along with the transient stability can be analyzed with this Power World simulator. So when we open the window of Power World simulator, you can see the first view, it will look like this. So when you pay attention that we have to open a new case if we are designing the new network. So when this software, whenever we are dealing, so if you want to create the file, this is one of the way we need to proceed. So when you open a new case, you will come across the ribbon and you will use have the various tools which is visible on your screen. That is application title bar, help button is there, quick access toolbar is there, file menu is there. But if you observe it, you will find that below file there will be two different mode. One is edit mode, one is run mode. So whenever we are dealing with this Power World simulator, whatever drawings we want to prepare, we are going to prepare it in edit mode, and whatever the analysis we want to do, we have to do it in run mode. So if you see the edit mode, when you click on edit mode, drawing tool, the drawing tab, this will be activated, and from that you will find the various components like your generator, your buses, your loads, your shunt connections, everything you will find, and you can prepare a drawing as per your analysis requirements. So in edit mode, when you go, if you want to do the simulation, one tool is given, solver is given. Once your drawing is prepared, once your network is prepared, you can go to the tools and you can click on this green play button. Once you play it, your solution will be done and you have to analyze the data. But if you pay attention, along with the play simulation option, there are various add-ons are available. By selecting various add-ons, what you can do the fault analysis, contingency analysis, contouring, GIC. The other analysis will be done, and all this will be activated only in edit mode. So if you want to, this slide gives you the idea that if we want to add some shortcuts, quick access toolbars, we can add it like this, add to quick access toolbar. So basically overall, by large, this simulator Power World will work in two different modes, edit mode and run mode. In edit mode, you have the task, you can create new power flow cases, you can modify existing cases, and this has the abilities that you can modify either graphically or via text displays. In run mode, as I have discussed, that this many tasks can be done. This many analysis can be done. A standalone power flow analysis tools and sensitivities like contingency analysis, time step simulation. You can do the weather simulation. You can do the weather data analysis. Means at various time duration you can enter the various weather conditions, and you can analyze the weather impact on the network. You have the optimal and power flow, ATC analysis, loss analysis, fault analysis, transient analysis. All these tools will be only activated in edit mode. So whenever you want to go for analysis, you have to switch. So as I discussed, if you want to prepare a new file, you have to go to edit mode. You can switch to edit mode at just about any time during a simulation, and you can create new files and you can modify the cases in edit mode as already discussed. So as we are going to proceed to create new file, what we do, in file menu we create the new case. So when we do it, what will happen, that this new case will be switched to edit mode, and we can prompt to save any existing case. Then it displays to default one line background color. Case may be built by graphically placing objects on the one line. Now we are going to discuss one simple case, that two bus system where we are going to connect a generator and load to the buses. We are going to discuss the power exchange between the two buses. At one bus there may be a load, one bus there may be a source. So for that we are going to first select the bus in PowerWorld simulator. When we select the bus, we have to insert the bus information, and bus information we are going to insert the voltage ratings, bus number, area number that we have to insert. So that can be done once selecting a bus. So when we select the bus from the draw option, one window or one dialog box will be there. It will look like this. If you pay your attention, you will find that bus numbers will be there, area, zone, owner, substation, everything we can define nicely. At the bottom part, if you observe, you will find that bus information, display, attached device, geographical conditions and custom things can be added if we want to add the further details. But if you want to go for simplest case, just we have to select the bus information and bus voltage we have to enter. If you pay your attention to second slide here somewhere, maybe majority of you are dealing with this electrical engineering, so you have the idea that whenever we are doing the load flow analysis, one bus we have to select it as slack bus. So generally a bus which is connected to generator, we select it as slack bus so that we can go for the solution. So here is one checkbox is there. If we select that checkbox, we can select or we can make one particular bus as slack bus, and then we are going to attach generator to this bus. So first by default we have to select a bus, then we are going to connect generator to it. So similar way we go to the edit mode in draw. In draw, from draw option we select a generator and we are going to set the generator data. So if you see the dialog box of this generator, you will find that you have to enter this many details. So let's say if you are using it for first time and if you are not going in much detail, if you want to do the very basic load flow analysis, what you need to do is you need to define the generator voltage and power. Power you can enter any megawatt, and if you have the specific data, you can enter that data in this software. So in power and voltage control, here if you observe, here you have to enter the power rating and voltage rating. In this power you have to enter what will be this generation, active power generation. So let's say if you are setting 100 megawatt, then you have to also define the maximum and minimum limits of generation of active power, as well as you have to define the reactive power, what will be the maximum reactive power and what will be the minimum reactive power generation. And there are two further options. If you pay attention to this dialog box, when you click on this power, one is the AVR and one is the one is your related to automatic voltage control, and one is for your the one is related to availability of modifying the power generation with respect to load demand. So when you open the case, this will be, when you open the new file will look like this. In draw you can see that network option is there. So from network option, right now whatever we have discussed, that we are going to first select the bus, we are going to enter the bus details, bus voltage ratings. After selecting the bus voltage ratings, we are going to enter the generator details and we are going to attach generator to the bus. And as you know that we have selected that generator is our slack bus, means generator is connected to slack bus. So if you pay attention, you will find that this generator map is slack bus. It is connected to slack bus. And this 0 megawatt and 0 megawatt MVR, if you observe, you will find it that it is nothing but it is a field values. Many a times in whenever you are dealing with the MATLABs or other things, you have to, if you want to see the data, you have to take the help of scopes. So here in PowerWorld simulator, whenever you are dealing, you can display the values in two different ways. One is with the field values, one is with the pie chart. So pie chart option is upcoming, so I'll show you that how pie chart is going to display the various information. So these field values are available for generators, transmission line, load, whatever components you are selecting. For that, these field values are available. So if you pay your attention, here you will find the field value. From field value, you have to select that whether you want to display the generator information, load information, or line information. From that, you can select. And after selecting that, you can put it around generator. Now, the thing is, every time there is no need to give numbering. Like you are dealing with many softwares, you have to give numbering, you have to go for sequencing. The nice thing about this software is numbering will come automatically. Just you have to place this field values near to component. It may be your generator, it may be your transformer, it may be your line, may be load. Now we can save the case. So for that case, save case option is available. So that is a very simplest thing. We are not going in detail. Now about this PowerWorld simulator, we have the two things in this simulator. One, we want to store data, and one, we want to display. So whenever we are doing the analysis, we have some information in terms of tables. So we have the facility to store that data into .pwd file format, and display is storing the information, display objects, whatever right now you are observing, this display objects, that will be stored in .pwd file format. And if you want to share this file, let's say you have created this file, and if you want to share it, you can share it with the help of .pwp. So in that, both the file formats will be combined, and you can share it with others. So one is to store the data, one is to store the display information, graphical information. So two different file formats will be there. Now when you select the second bus from the draw option, the numbering will come automatically. The numbering will come automatically, and similarly you have to enter the bus voltage. Once you enter the bus voltage, the task is done. Then you have to select the load for that particular bus. So I come to this point, but when you go further, you will see like this, that there are two different buses. If you pay your attention, you will find that at one bus a generator is connected, at another bus a load is connected. And if you pay attention, you will find that a near generator as well as near load field values are displayed. Now this square red boxes, that gives idea that it is nothing but it is circuit breaker. So if you want to remove the line, or if you want to remove the generator, or if you want to remove the load from the network, you can just click on these square boxes. So it will be out of the system, and you can simulate your contingency cases. So various contingency analysis if you want to do, just you have to click on this square boxes, so that the component will be out of the network. In between two buses, if you observe that one transmission line is there, so this transmission line will carry power from generating bus to the load bus. And when you go for this, just a second. When you run the simulation case, you will find that this kind of scenario will be there, whether it will be 2 bus or 3 bus. If you go for the analysis, you have the 1 bus system, 2 bus system or 3 bus system. you can see the load flow analysis. I think many of you are getting this just by visualization. Compared to this, if you have another package, you have to interpret that what will be the direction of power flow, what will be the active power losses, what will be the reactive power losses. So in that case, it will be very, very difficult for everyone to correctly judge what is happening. So this is one of the example of 3-bus system. This green arrow indicates the line loading. If color, let's say we have the custom settings in load flow analysis, that if we set the line loading of 100 megawatt, if line is loaded above 100 megawatt, that this current will be, this color of this transmission line arrow will be changed. It may be turned into red as per our modification into the software package. We can select any color, but just to see that some violations are being occurred in the line, what we are doing, we select the red indication, and you have the two different options. One is, if you see this circle is nothing but this circle is pie chart. It is representing that various information. You can represent or you can display the current passing through the transmission line. You can display the megawatt loading of the line. You can display the active power flowing through the line, reactive power flowing through the line, active power losses, reactive power losses. Any information which is helpful you can display on this pie chart, and that is as per our choice, that which data we want to go through, which data we want to utilize. Now, whenever you are going to do it first time, the difficulty you will feel that many a times when you go in run mode, these pie charts are not coming by default. When you see it in edit mode, this pie gauge will be there, pie charts will be there. But when you go in run mode, it will be not there. So you have to modify some settings of the pie chart so that it will be visible. So you can see, as I have discussed, that we can select the different cases, or we can modify the color combination and display objects as per our choice. So these are the color codings for our networks. Now, I told you that there are two ways to display the information. One is field value, one is the pie chart. So if you want to add the multiple field values, you have to use this default drawing values for new objects, so that you can place various information next to bus. One is megawatt, active power flow, reactive power flow, active power losses, reactive power losses. You can display at both the sides, because you have multiple components. For each and every components, you have to select which values you want to display, and for display, these are the ways you have to follow to get the information. You can select the various data as per the areas, as per the bus numbers, circuit breaker, zones, and various things. If you want to select or display some particular information, you can select that thing by selecting one particular criteria. So you have the multiple criteria selection. Here field bus is selected, so you can select the number of buses. You can select the various zones, various areas, various screen layers in this particular dialog, and you can get the particular information with this PowerVoid simulator. You have the advanced filtering options also to select the various information. You can format your data. These are the glimpse of the formatting options you can select. When you right click, you will get the format selection, so you can modify your displaying objects and everything. So you have the active power information, reactive power information, but the one new thing, if you observe, you will find that some cost is being displayed. So whenever you are doing the locational marginal prices, LMP analysis or that thing, cost analysis, this software is a user-friendly tool to get the cost analysis. But for that you have to accurately define the cost model, and that cost model defining is only possible in generator information. So whenever you are defining generator, you have to define the cost model, fuel cost model. So if you are defining it rightly, you will get the real pricing. You can format the displaying objects. You can change the colors and other things. You can change the direction of orientation of the displayed data by selecting this green circle. So you can rotate this displaying information. If you observe this black boxing, you can resize the this displaying information. So these are one more thing related to cast that editing, that how much zoom you want to, how much zooming you want to do, how much resizing you want to do of your data. You can change the data size, you can change the orientation of the objects by changing the display left, right, up, down. You can move or rotate your objects with the help of this right, up, left, down. So means you can change that that generator is connected on downside, upside, left side or right side. So that are the editing options. Font can be changed. Now, as I discussed that, I'll try to discuss this my talk in two parts. One is related to how to deal with software package, and second thing is how to deal or how to do the analysis, load flow analysis. So whenever we are dealing with the IEEE 5 bus, some information is with us. That information is in terms of transmission line data. So whenever we are dealing with the transmission line designing, we need 4 data. First one is resistance, reactance, susceptance and conductance. So that 4 displays as per this standard data are available on IEEE website. So we can select various data. This data are particularly being used to get the real-time analysis. Same to same analysis if we want. So what we have to do, we have to enter the correct data. So when we enter the correct data, what we will get, that we are going to get this kind of load flow analysis. This is being represented in terms of drawing. You see, if you pay your attention in the data, first we pay attention to our data, that bus number 1, totally the IEEE 5 bus data means 5 buses will be there. So some informations will be given, some informations will be missing. So missing values we are finding with load flow analysis. So if you see that, if you pay your attention, you will find that generator 1, generator 2, that this information is not available. So what we do, and before I discuss this, if you pay attention that generator is connected to bus number 1, bus number 2, and rest of the 3 buses, out of 5 buses, 2 buses are connected to generators are connected to 2 buses. Rest of the 3 buses are having the load connection along with the bus number 2. So if you pay attention, you will see that whenever you do the load flow analysis, the active power generation at bus number 1 will be around 129.585 megawatt. The reactive power will be at bus number 1 will be minus 7.421 megawatt ampere reactive. For generator 2, you will find that generator 2 generation will be 40 megawatt active power and 30 megawatt will be the reactive power. Now you are finding, let's say we are selecting one bus that is between bus number 2 and bus number 5, if you pay attention, that 6 informations are being displayed. So when you look here, you will find that first information is 54.82 megawatt. That is active power is being flowed. Active power is flowing from bus number 2 to bus number 5. Reactive power is around 7.34 megawatt ampere reactive. So whatever you are transmitting, whatever you are receiving, there might be some difference. There will be line losses. So if you pay attention on the bus number 5 field values, you will find that receiving end power, active power is 53.698 megawatt, and the reactive power value is around minus 7.16 megawatt ampere reactive. So whatever being sent, whatever being received, there is always a difference because there is a distance, and in distance you have the transmission line. Now if you enter that resistance value will be 0, then it will be a lossless line. So you may have the 100% efficiency. So whenever you are entering data, you have to be very careful to get the realistic data. So you see that the difference in active power is 1.125 megawatt, that is active power loss, 0.176, that is reactive power loss. So similar way you can observe at each and every bus the active power, reactive power loss, sending end power value, receiving end power value. So whenever you are doing the analysis compared to any other software, let's say if you are taking the example of MATLAB software, everything is available in tabular form. Even if you want to identify the direction of flow of current in MATLAB, then you have to see the voltage ratings as well as you have to see the power angles. And you have to recall that what will be the scenario. And that thing you have to do it for each and every bus. So compared to that, whenever you are dealing with this PowerMax simulator, it is extremely simple. Data analysis, any fresh student even can, if I introduce this topic to any newcomer or fresh student, then also just because of visualization, he will understand what is happening. So this is a very user friendly software. So this is the one of the case we have discussed in that case of IEEE 5-bus system. Now one more thing, one more feature, if you observe that I kept this second diagram of same thing, but if you pay attention that this IEEE 5-bus is there, if you want to inspect that what will be the overall scenario, what will be the total cost of operation, what will be the total losses in area, what will be the total connected load, what will be the active power load, what will be the reactive power load, what will be the active power losses, reactive power loss, what will be the hourly cost operation. So if those kind of analysis we want to do, then we need not to go for the calculations. One more time we can select the area field option. Like I told you that we are having the field options. So in field option we can select the area field, and in area field if you pay attention, you will find that this side around 165 megawatt is connected load. So what is the beauty is that you are investing less time in your analysis compared to other software packages. You are not need to summarize everything, you no need to calculate each and everything. Direct summary is possible. So you have the 165 megawatt connected load, 169.56 megawatt is being generated, that is power generated, 4.59 megawatt that will be the active power loss, minus 17.43 megawatt ampere reactive, that is reactive power loss. Similar way you can display the cost and this voltage information, bus angle information, you can display it in two different way. One is in per unit, one is, let's say if you want to display the fault current or if you want to display the ampere rating, you can display in two different way. One is the per unit system, one is the ampere system. So that kind of feasibility, flexibility is there. So analysis will be extremely simple and it is easy to handle. So this is same thing, but this will be a pictorial view. This is a case study simulated. So this kind of view will become visible in PowerWorld simulator whenever you are doing the load flow analysis. Even you can do the contingency analysis. Contingency analysis is what generally what we are doing. We are trying to check what will be the effect of failure of either generator, either transmission line, either load. Because we are worried sometimes that if any of the component gets fails, what will be impact of it on rest of the system. So that is called contingency analysis, and generally contingency analysis being done in terms of individual elements or in terms of combination of your line source, or maybe in terms of combination of anything, generation, line, load. So you can do contingency analysis. Whenever you do the contingency analysis, direct violations will be indicated in reports. So you can observe that what kind of violations will be there and which element is showing violations, whether there is under voltage condition, over voltage condition will be there. That violations monitoring will be there. So you will be prepared in future if there will be any kind of fault or any kind of disturbance in the system. You can easily take care of those disturbances if you did the contingency analysis. So contingency analysis is also one of the add-ons in this PowerWorld simulator. So whenever you do the IEEE load flow analysis, you will see that one point we have discussed, that generator 1 data is not available. So generator 1 data you can calculate by doing the load flow analysis. Similar way, if you see the bus voltage information along with its angle, so that can be also available through this this kind of load flow analysis. Now this is one of the case study which can be done. So similar way, whenever I am telling you that there is contingencies will be there. So to have the contingencies, what we can do, we have to create the failures. So fault analysis also we can do. So I will take you to the one of the case where we can discuss the fault analysis. That fault will be as per already you know that there will be two kinds of fault in power system. One is symmetrical fault, one is unsymmetrical fault. In symmetrical fault, all the three lines will be involved participating during fault, and in unsymmetrical faults, you know that single line to ground, line to line, or double line to ground faults will be there. So one more case we discussed. So let's say some network is given in this form, where generator is there, transformer is there, and 3-bus system is there along with their impedances. And the star connection, maybe you come across this study whenever this star with neutral reactance or that thing is given. That is useful for zero sequence components of current, because whenever we are doing the hand calculations, we are doing it with the if balanced fault, unbalanced faults are there, symmetrical components, we are taking the help of symmetrical components to do the analysis. So all the informations are given, and fault impedance value is also given. That let's say fault impedance is 0.16 ohm. So you can prepare the network diagram in PowerWorld simulator like this. It is extremely simple. If you want to prepare this diagram in this form, you have the 3 different buses, you have to select 2 generators, and you have the pi gate that is going to display the information. Now whenever you go to the edit mode, to the run mode, you will find that where there are one tools, and along with tools there are add-ons. So when you select the add-ons, in that you have to select the fault analysis. So when you select the fault analysis, this kind of dialog box will be there, and in this case specifically we are going to create the fault at bus number 3. So at bus number 3, so if you see in dialog box, you will find that fault location is there. So we have to define fault location, whether it is inline fault, bus fault, what will be the fault type. whether it will be single line to ground, line to line, three-phase balance fault, or double line to ground fault. And here we can insert, as I have told you, that there is one data given, that data is telling us that fault impedance will be 0.16 ohm. So that 0.16 ohm is being entered here. If you observe, that 0.16 ohm reactance is being entered here. And whenever you go to the run option, you can display your fault current in two different ways. One is in per unit, one is in ampere. So whenever you do it, your fault current magnitude is directly being displayed. That fault current will be 2 per unit. So this fault current magnitude will vary case to case, because the single line to ground, line to line, double line to ground, different faults will be there, different fault current magnitudes will be there. So that information you can easily do, or you can do the fault analysis at any location. Just you need to define location here. This is like a selection. You can select any location, you can select any place, any kind of fault. Within the moment your analysis will be done. Just you need to interpret the data. So data interpretation, that is the task in this kind of simulator package. So here if you see the results, if you see this 1.2 and 0.8, that is contributing to this 2 per unit fault current magnitude. So data you can fetch it in tabular form, and you can interpret that how it is 2 ampere. So 1.2 plus 0.8, that is making 2 per unit. That will be the information is being displayed here in dialog box. That will be the magnitude of fault current. So similar way, line to ground fault we can do for same data. We have the various fault currents. It may be 2.75. Now line to ground is there. So fault current magnitude is 2.75, and this is single line to ground fault. So same example, same data, same case study. What we are doing is we are changing the fault type, and we are getting if the fault type is being changed, what will be the magnitude of fault current. So similar way you can get the results. Similar way line to line. So when you same case study, if you do the line to line fault analysis, your fault current magnitude will change. Now line to line fault analysis, when you do, you will find that your, let's say if you have the three-phase system RYB, if you are going to create the fault on Y and B phases, both the fault current magnitudes will be same, but the direction will be opposite. One will be in forward direction, one will be in reverse direction. So magnitude will be same, direction of it will be changed. And compared to this, whenever you are doing the double line to ground fault analysis, both the B phase and C phase current will be additive. Let's say Y and B will be there, so both will be additive. So you are getting the data, just you need to interpret what will be the scenario. So this will be a case or magnitude of fault currents whenever you are creating the double line to ground fault. And whenever we are doing this kind of fault analysis, one thing is clear, that we are making the one assumption that fault current is only flowing through the faulty phases. In the other phase, by default we are assuming that there is no flow of current. So that thing, if we keep in mind, we will match our theoretical results with this practical calculations, practical analysis. So this is a complete PowerWorld simulator package. I have tried to cover the case studies along with the in how to deal with software and case studies. So thank you everyone. Thank you very much.
After the એન્ડ ઓફ ધ બોર્ડ ટેકનિકલ સેશન્સ. હા કોણ કાગળ નથી લાયા શુક્લા સાહેબ તમે તો યાર. માઇક આપો એમને. એમનો ક્વેશ્ચન પૂરો થઈ ગયો.
Sir,